All right, folks, here we go with the second chapter now. And the second chapter deals with what we call polynomial functions, okay? You've looked at these before, you've dealt with a bunch before, you just might not know that they're called polynomial functions. If you've been in my class, I've talked about polynomial functions as being a family of functions, of which you've done 2 or 3 of them already. But the idea is there's patterns in these polynomial functions that are predictable and allow us to visualize higher level functions of these. So first of all, they're a family of functions with predictable patterns, okay? And they look like this. They look like, well, f of x as well, right? F of x. So ax to the power of n, bx to the power of n minus 1, so it would be 1 less. If you thought about it, you could think of it as being 2x squared minus 3x plus 1, where this is your a, that's x squared. 1 less than 2 is 1, and then that ends and you end up with a constant at the end, right? This is your constant at the end because it's something that doesn't change. It's the last number, and a number is always called a constant, so the constant here is 1. Now you could kick it up to the next one. What about 2x cubed minus 3x squared plus 1x minus 2? So now this is your n minus 1, n minus 2, and then your constant at the end. And these numbers in the front are just coefficients. They can be any rational number, okay? Now, if you think about this, you've seen these before. These have a degree of 2. The highest exponent is a 2, and it's called a quadratic. This one here has a highest exponent of a 3, and that's called a cubic. If you look at something that has a power of 1, that would be called a linear equation. What about if you had a power of 0? Well, you know, that's just equal to 1, so that's 2, and that's called a constant function. So these are all what we call polynomials. And what I'm going to give you right now is a quick sort of summary of all these things. And we're going to look at what the graphs look like and the number of solutions and a bunch of terminology here, okay? So first of all, what we're going to look at are linear functions, okay? Y equals x to the power of 1. The degree here is 1 because that's the exponent. The number of solutions that you have is 1. Solutions are where they cross the x-axis, remember? Okay, a solution is where it crosses the x-axis. Maybe that's something we want to write down here. Solutions, okay, they're the x-intercepts, if you can remember. We often look for those. Those are of importance to us. They're also called a couple different things. They're also called zeros to the function or roots to the function, or yeah, that's basically it. Solutions are the x-intercepts. They're also called zeros and roots, okay? So that's how many times it crosses the x-axis. Now, with the linear function, it only crosses once. It could be anywhere, though. What I'm showing you here, too, is what a positive graph, the leading coefficient, right? So the difference between a plus 2 and a minus 2. 2x or minus 2x, right? This would be plus x, so this would be y equals x, and this would be y equals negative x. Okay, so we're going to look at the positive and the negative versions because that's part of what we got going on here as well. Okay, so quadratic, highest degree is 2. So it's an x squared. How many solutions can it have? Well, you probably remember a couple things here. You probably remember that a quadratic is a parabola. How many solutions can it have, right? It can have 2 solutions, it can have 1 solution, or it can have no solutions. So I'm going to say between 0 and 2 solutions. And a positive one, I'm only going to show you the basic one, okay? There's the positive version, and there's the negative version, okay? Up or down. So the next one we're going to look at is what we call cubic. And a cubic function looks like this, y equals x cubed. And you guessed it, it has a degree of 3. How many solutions can it have? Well, let's think about it. A cubic function, if you remember what it looks like this. It has negative values because when you cube a negative, it remains negative. If you look at the quadratic, when you square a negative number, it becomes positive. So we're going to look at differences here between even and odd functions. All even functions behave similarly, and all odd functions behave similarly. So what I'm going to do first of all here is I'm actually going to graph this bad boy. It looks something like this, and then the negative version looks something like this. Okay? Now, notice that it has to cross at least once. So we have one solution, and you can have a maximum of up to 3 solutions. And how that works is that if this is the original function, right, y equals x cubed just looks like this. But if I start adding, say, 2x squared or minus x squared and all the rest of that jumbo mumbo at the back, what happens to my cubic is it can start having these various terms in it. Here's a situation where I can have 3 solutions, right? And here's a situation where I can have 2 solutions. Here's a situation where I have 1. But you can never have 0. It always has to cross once because with the odd functions, they end in opposite directions. That's what we call end behaviors, okay? End behaviors are where these functions are going at their ends. So that might be something that we want to write down here too. End behavior. It's either positive infinity or negative infinity. It's where is the graph going on each side. Okay, so that's what we have here. The end behavior here on the left side is positive infinity. On the right side, positive infinity. On the left side, negative infinity. Here, they both go to positive infinity. Here, they both go to negative infinity. Here, this one's going up, this one's going down. So yeah, end behavior is looking at where the function is going as you go to positive infinity for x and to negative infinity for x, okay? Now the next one, hopefully you can kind of see what we're doing here. It's going to look like y equals x to the power of 4, okay? And what that does is it's going to give us, let me just sharpen this pencil here, it's going to give us something similar to the quadratic function because it's an even function. Now, it's a degree of 4, and I can have between 0 and 4 solutions, and I will show you why. And a steep, this function right now, okay, is just a steep parabola, because if you go over 1, you go up 1. Well, I didn't do that right, but then you go over 2, you go up 2 to the power of 4, which is 2, 4, 8, 16. So it's just a steep parabola. But the thing with this stuff, guys, is we are increasing the complexity of these things. So sure, it can be just x to the power of 4, but what happens if I have a minus 3x squared plus a 2x, cubed plus a 2x squared minus an x plus a 1? All these additional mumbo jumbo at the back changes what my function is going to look like, what my graph is going to look like, okay? So yeah, it can just have one solution like this, but it can also have a couple humps in it like this, and now we have 1, 2, 3 solutions. Another example would be, look, you've got 1, 2, 3, 4 solutions. That's about the maximum amount of solutions that you can have, all right? But you could also have 0 solutions if it was something like this. You could have 1 solution if it was something just touched once and then it did this. Okay, so 1 solution. Here you have, you could have 2 solutions, 3 solutions, 4 solutions, no solutions. All because we understand what the behavior of these things are. Now notice that we're getting terms in here, right? Notice that the, let me break it down here for you. So y equals x to the power of 1, no turns, right? No bends. Y equals x squared always has 1 bend. Y equals x cubed can have a maximum of 2 bends. Y equals x to the power of 4 can have a maximum of 3 bends. We'll take a guess what y equals x to the power of 5 looks like, okay? That's going to be like these odd ones. They're going to end in opposite directions, but you can have 4 different turns in them, and it just keeps growing like that. Y to the power of, y equals x to the power of 6, even, so they end in the same direction, and I can have 1, 2, 3, 4, 5 turns in it, and it just keeps going and going and going. This is the positive one, this is the negative one, right? This is the positive one, this is the negative one. So I'm actually not going to use this in here. I'm going to use plus dot, 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 dot here, and I'm going to show you that it looks like that, and that the bottom one, okay, can look like this. And then the x to the power of 5 one here, y equals x to the power of 5, that's called a quintic, okay? And then boom, 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 boom. and it's an order of 5 or a degree of 5, and it can have between 1 and 5 solutions. Okay, so a couple things that we're going to have to sort of look at. The degree indicates the maximum number of solutions, right? That's something that we can write down here. That's an important point. The degree of a polynomial function tells us the max number of solutions. Another thing that we can see here is that odd functions always have at least one. Odd functions have to cross at least once, right? All odd functions have to have at least one solution, okay? All even functions can have no solutions, okay? Because they can either be up top here or down below. They could be up top here or down below. They don't have to cross, right? Positive and negative, right? So for even functions, let's look at odd functions again. Odd functions, okay? End behaviors in opposite directions, right? End behaviors opposite, right? Even functions, end behaviors the same. So they either open up, we call it open up, or down. And notice with the odd functions, a positive always starts in the bottom left, bottom left, bottom left. An odd function, the negative version, always starts at the top, top, top. So you know that an odd function always goes like this. You know if it's positive, and it goes like this if it's negative. An even function always opens up if it's positive, always opens down if it's negative. These are patterns that are very useful when we start sketching these things, okay? Now, what else do we have to look at here? We've got a couple other points that I wanted to bring up. We often get our functions in factored form. Let's look at a couple points here. The constant, okay? The constant in any given function, the constant in a polynomial function is always the y-intercept. The constant in a polynomial function is the y-intercept, okay? We talked about the number of turns, right? So a quintic has 1, 2, 3, 4 turns. So a quartic has 3 turns, potentially. A cubic has 2 turns. So x to the power of 12 would have possibly 11 turns in it, okay? But so these are patterns, hopefully, that you're going to see, hopefully that you'll be able to sort out. Now let's quickly talk about a couple things here. If I gave you f of x is equal to, let's break it down into factored form. So I'm going to go x squared times x minus 3. Hopefully what you can find out is your solutions. Your solutions are what, right? It's what makes this whole thing 0. Solutions are when y is equal to 0. So you make 0 here, x squared times x minus 3. You're solving a quadratic, or in this case, what's it going to be? It's going to be a cubic function, because if you multiply it out, you're going to get an x cubed. So the solutions here, since x squared, so you got x equals 0, you got x equals 0, and you got x equals 3. These are solutions. This is what we call multiplicity. Okay, what's the multiplicity? There's 2 of the same solution. Hopefully you remember what happens when you have what we call a double root, okay? If you look at a graph, it means that it crosses here and here, okay? Now, it's a cubic, right? It's a cubic function, which means that, and it's a positive. It starts off with the positive number at the front. I'm not sure if I indicated to you why these are negative. They're negative if their leading coefficient is negative, right? So when you look at this thing, if this is negative, then it opens down. So if, let's put that here, a less than 0, no, I can't really do that. If it's less than 0, it means it opens down, or it goes like this, okay? Starts at the top left for an odd function, or it opens down for an even function. So where was I now? Yes, here. So since this is a cubic, it's a positive, it starts down here. What happens at a double root? It doesn't go through, it bounces. And then I know I have to go through here. And you get a pretty good idea of what the sketch looks like. This is where we're trying to get to, right? If I give you a function that looked like this, f of x is equal to x times x minus 1 times x plus 2 times x minus 3. Well, you'll be able to tell me that if you're looking for the solutions, you make this 0. You got x equals 0. You got x equals 1. You got x equals negative 2. And you got x equals 3. So when you graph that up, 0, 1, negative 2, and negative 3. This is a quartic function. It's an x to the power of 4. Because if you multiplied them all out, you'd have x to the power of 4. It's positive, which means that it opens up. And it looks like our little W if you look back at your graphs, okay? It's an x to the power of 4. It's going to be one of these. If it's positive, it looks there. 1, 2, 3, 4 solutions. Look, 1, 2, 3, 4 solutions. So we just sketch it in the best we can. That's basically what we're looking at, okay? Let me give you one other example here. If I have f of x is equal to x minus 2 cubed times x plus 3 squared. Okay, solution, make this equal to 0. Now you have x is equal to 2, 2, 2, negative 3, and negative 3. The reason I write them all out is because it helps me understand what it is that's happening. So I know it crosses at these 2 points. Now what happens with a triple root now? A double root, we know that it bounces. What do you think happens at a triple root? It goes right through. Okay, what about if you had 4 answers? Same, a quad root, 4 roots the same, it would bounce. 5 roots the same, it would go through. So a multiplicity of 2, bounce, multiplicity of 3, through. Multiplicity of 4, bounce, multiplicity of 5, through. Multiplicity of 6, bounce. Okay, maybe that's something we want to write down. Whereas those notes that I was writing down here. Anyway, let's see, we can put it down here. Okay, if we have an even multiplicity, right, it bounces off the x-axis, bounces off x-axis. If it has an odd multiplicity, it goes through point, goes through the 0. Okay, so what would this one look like? Well, you know what? We could take a guess. It's a positive one. If I put a negative out front, let's do that. If I put a negative out front, it means it starts up here and it goes through there. Who knows what it does here everywhere? I don't know what it does, but then it bounces here and comes back down. I don't know what happens in here. We'll have techniques to find that stuff later, but that's basically what we're looking at here, folks, okay? Solutions, you're going to have to remember what solutions are. They're the zeros to the function. I would suggest reading the section in your notebook or your workbooks to get an idea of what it is that we're looking at. And yeah, any questions, we'll deal with them in class.